Guys, today we're taking a look at algebraic proofs. Now, in geometry, it's pretty customary to do what's known as a proof. And a proof is simply a way of organizing your logical statements and backing them up with logical reasons. Those reasons can be theorems, they can be definitions, they can be properties. Well, today we're going to start off by looking at algebraic proofs. In other words, we're going to look at solving an algebraic equation and giving a reason for every step that we make towards its solution. So let's start off by learning some of these algebraic properties. The addition property of equality simply states that if we have two things that are equal to each other, like A and B, so if A equals B, then if I add the same value to each side, they'll remain equal. So that should make sense, right? The subtraction property is similar. It says if two things are equal, if A is equal to B, then if I subtract the same amount from both sides, they'll again remain equal to each other. The multiplication property is the same. If A is equal to B, then I can multiply the same amount to A and to B, and they'll remain equal to each other. The division property of equality, you may have guessed it, reads the same. If A is equal to B, then A divided by some number C is equal to B divided by that same number C. All right, the reflection property of equality is simply A is equal to A. Now, that might seem kind of, intuitive, but there's reasons why we have that property. The symmetric property of equality states this: if A is equal to B, then I can switch those two things around, the equal sign, and they'll remain equal. So in other words, B is now equal to A. The transitive property of equality is a very useful one. It says if A is equal to B, and if B is equal to C, then I can conclude that A is also equal to C. The next is the substitution property, and it simply goes like this: if A is equal to B, then B can replace A. All right, let's take a look at a few more of these properties that we're going to use. Now, instead of properties of equality, we're taking a look at properties of congruence. So you're going to notice just a slight change here. The reflexive property of congruence simply says something is always congruent to itself. So A is congruent to A. Now notice we swapped out the equal sign for the congruent symbol. The next thing here is the symmetric property of equality, and it says this: if A is, it's a symmetric property of congruence. If A is congruent to B, then I can turn those things around, and B is going to be congruent to A. And finally, the transitive property of congruence states if A is congruent to B, and I know that B is congruent to C, then my conclusion is that A must be congruent to C. All right, so let's look at a few examples and just applying some of these theorems and properties of equality and congruence to some algebraic proofs. First of all, let's just identify these following statements here. I got angle ABC is congruent to angle ABC. Well, right up here I see that that's the reflexive property of congruence. All right, so we're going to make sure we say it, reflexive property of, of congruence. Next, we see that segment AB is congruent to segment CD. We know that segment CD is congruent to EF, thus AB must be congruent to EF. So if you take a look here, AB is congruent to EF by this link here, CD. So that's this transitive property of equality. I'm going to write out transitive property of congruence. Not equality, of congruence, because we have these congruent symbols here. Next, we see that 23 is equal to y, thus y is equal to 23, and this is the symmetric property of equality. All right. So just trying to get you to be able to recognize those when you see them. Taking a look at the symbol here, this is an equality. These were congruents, so there's a difference in those properties. All right, let's jump into the meat of today here. It says here to solve this algebraic equation and give a justification. And remember, justification is just another word for a reason from the list above for each of the following steps. So that list above is our list of algebraic properties that we're going to refer to. So this first step here is 1/2 of some number t plus 1 is equal to -7. I'm going to start off by saying this is my given equation. Now let's start solving. You see, in order to solve this, we're going to move our 1 over by subtraction. So what we're doing is we're subtracting 1 from both sides. And this is known as the subtraction property of equality. Remember, the subtraction property of equality said if you had two things that were equal and you subtract the same thing from both sides, that they will remain equal. All right, now I have 1/2 t is equal to -8. Our next step here, looks like we're going to get rid of that 1/2 by multiplying both sides by 2. So when I multiply both sides by 2, I'm applying the multiplication property of equality. All right. So once I've multiplied both sides by 2, the 2's now cancel out on this side, and I have t is equal to 2 times -8, which is -16, and now I've solved my algebraic equation. And I've given reasons for each step along the way. Let's try another example. Example 2 says to solve the equation, giving justification for each step. Now notice I don't have lines set up here. That's okay. We're going to come up with our statements and our reasons. So our 2 columns here, and we're going to lay out our work. All right, our first statement is simply to write the given equation. 4x minus 8 is equal to -12. And this is what's given to me. All right. Next, I'm going to add 8 to both sides, and that's the addition property of equality. Whoops, I better spell addition right. All right. All right, next I have 4x is now equal to -12 plus 8 is -4. Make sure you're simplifying as you solve these equations. I'm going to divide both sides now by 4, and that's the division property of equality. And finally, my last step here is that x is equal to -1, and this is my solved equation. So one thing you might be noticing is that every operation we do, if I added, it was the addition property. If I divided, it was the division property. If I subtracted, it'd be the subtraction property. The operation that I do tell me the property that I'm using. All right, one final example for today. Example 3 says write a justification for each step. Use the diagram as a reference. So you see here I have NM and MO with these expressions for those segments. And it's equal to the whole thing. I see here that NO is equal to NM plus MO. Well, this is the segment addition postulate, if you remember back to chapter 1 or unit 1 of this year. So this is known as segment addition postulate. It says the two parts add up to equal the whole thing. All right, next I'm going to substitute in their expressions. So you see here for NO, it's 4x minus 4 equals 2x plus 3x minus 9. So here I use the property of substitution. All right, in our next line here, it looks like I'm combining the 2x and the 3x to get 5x. So this is called combining like terms. You could have also said the word simplify if you would prefer that. All right, next I'm going to add over my -9, so I get +5. So this is the addition property of equality. Next, I'm going to subtract my 4x over the other side. So here's my subtraction property of equality. Oops. And then finally, I have my solved equation. So I can say that it's solved. And so this is a little introduction to algebraic proofs.